This is a great resource for showing how the k-means algorithm works. Let's take a look at a couple of examples and see what might happen with different sets of data and different numbers of clusters. To begin, let's go ahead and choose a set of data, and maybe choose something like this Gaussian mixture. And imagine we put a centroid here. And so what this algorithm is telling us is basically all of the points belong to this algorithm at the beginning. And maybe we have another point here and a third point here. And we could run the algorithm. If we say go, you can see that the first thing that happens is each centroid is assigned to a certain number of points. And then if we update the centroids, they move to the center of that grouping. And if we reassign the points, you can see in this case none of them updated, the centroids didn't move, and what happens is the algorithm's done at that point because the centroids stayed static for 2 iterations. Now, if we restart and we choose the Gaussian mixture again, but let's say we have 2 points that are down here and maybe 1 that's up here. And so we think there's 3 clusters, and we run the algorithm like this. So the first thing that happens is all of our centroids are assigned, and then we update them, and then we reassign the points, and then we update the centroids, and you can see again we end up with the same clusters. This should give you some intuition behind how the k-means algorithm actually works behind the scenes, where it's finding the points that are closest to the centroid, updating the centroid, looking at the points that are closest in its new position, updating the centroid, and doing that until the centroid no longer moves. But let's see what might happen if something goes wrong. So let's do the Gaussian mixture model again. And we have 2 centroids that look like this. And we perform the clustering algorithm until it's done, and it ends up like this. But then if we restart and we have that exact same set of data, and maybe we put 1 here, we add a centroid down here, and we add a centroid up here, now running the algorithm shows that we get a different grouping. So it's not the case that the groupings will always end up the same. And which grouping is actually the best? This is something that we'll explore in the next concepts.